The recording started, and let me get my class note. Two part of our class today. One, first we're gonna do some theory. Okay. In last class, the major thing happened, which is the hints for homework. Okay. It's a very important class because the homework hints should able to help you. Homework number one. I think the deadline is today, right? If I'm not mistaken. When is the homework one is due?
Wednesday.
Oh, it was Wednesday last week. Last week or this
No,
Wednesday?
this week. Yeah.
Alright, so we're in good shape. So yeah, just follow that deadline for homework one, and in this Friday game, I'd say like I'm gonna give you the hints for homework number two. Is the homework two I already uploaded?
Yeah, the homework's there.
Number two is as well.
No, just one.
Just one, yeah.
Yeah.
Oh, it should be in backspace. Okay, let us all check. So this is not this. Oh, this is the course. Okay, so all right. Usually, I assigned it as a assignment. Okay, so if you're gonna go here, this homework one is obviously here. One students already submitted. Anything that you gotta do is under assignments. Yeah, essence. Yeah, the content sometimes. I mean, I can create a link for the same assignment, but if I'm gonna put it in the content, then there is no Dropbox. So like I'm gonna create that, right, a folder, and then yep, there is a means for me to do that. Just the connection. I forgot. Yep. Uh, in some classes I do for whatever reason I don't have it here. I'm not seeing it here, and it's just taking forever. I don't know waste your time on this. Anyway, so you see the location is in assignment. When it will come up, it finally came up. Um, all right, now you should be seeing under content as well. So homework number two, I'm gonna upload it today. Okay, and it's due. Today is what, like Monday, next Monday. Okay, there are like so many homeworks, so we gotta keep up with the homeworks. Okay, so next Monday. At some point you'll be seeing not giving you full week. So like if I'm gonna upload it on Monday, then maybe Friday's the deadline, something like that. So I'll give you a heads up. Not this time. Second one will be due on next Monday. So Friday would be like homework two hints. So for today's class, remember, what did we start in last class? We started with like rectilinear motion, right? Where it just goes straight. And then we had this new topic called curvilinear motion. Curvilinear motion means it is a curved motion, right? Whenever you have a curved motion, we had two examples shown. Remember, like the um, helical one for a roller coaster, and the other example is a bunch of fight jet is moving with some spray of rainbow. So we're trying to track of the path, like velocity, acceleration, and position, all sorts of things, right? And we started with the theory in last class. Let me show it to you first, and then we'll move from there. So we started with this theory, right, in last class. Just quickly shown it to you, like you obviously have these three different axes in this case, like x, y, and z, right? It should be the other way around. This one should be open, this one should be closed, so you can see it better. All right, so so I was just saying, like we had all those equations, right? Like this velocity, acceleration, and position equation. The relationship, we've seen it for three different axes, x, y, and z. Everybody remember so far? It's good. All right, and then we had this in second page. This simple vector thing I introduced, which we have seen it before in statics class as well. I have an I, J, and K, right, in x, y, and z direction. The unit vectors. It was good so far. Then you're good. All right, so perfect. Everybody's good up to this point. Now today's agenda. Let me quickly show it to you here. So this is the theory agenda, okay, and then we just have one math, okay, not too much. So position, velocity, and acceleration. Now this time we'll be exploring that for these three different axes, x, y, and z, right? So we're gonna deal with this thing in terms of vectors. First of all, so after we're done with that, then there's this math that we'll try to solve. As you can see, let me give you a little brief here. We'll talk more when time comes. But here you're seeing a card has a start position of 2 and 6, okay? That's in the coordinate system. X value 2, Y value 6. And then it's just moving. After some time, it's asking 2 seconds, right? It's asking different things like the position, velocity, acceleration, those sort of thing, right? And they give you two equations, the velocities equations, because it's a 2D case. Everybody see that, right? X and Y. It's a 2D case. So they gave you the X direction velocity and Y direction velocity. So which tells you like, to find the position, you got to do the integration, right? dv, v equal to ds over dt. So to find the position, that to find the acceleration, what you got to do? dv over dt means you got to do the derivative. Okay. So this is the whole overview of what we'll be seeing next 30-40 minutes, whatever we have left. Any question? Okay, moving on to the exact theory. Obviously, the lecture is in record. Okay, so you'll have the access both today's and last class lecture. End of the class, I'll try to put it. Okay. All right. So let's just start a little slow because this is the real material. Everybody, please start taking the class notes. So the position first. Okay, the position you would be seeing. I mean, before you have seen the position. You refer it by S when you didn't do the vector, right? Everyone remember that like ds over dt was the velocity, the S was the position. This time you'd be using this R vector. Anytime you see me putting a line on the top of the R or any parameter per se, that is referring to the vector. You know that. So this use of R rather than S. Now, sometimes people also put like an arrow like this on the top. It really doesn't matter, different convention. For vector, you can use a line on the top as well. Or sometimes people use like the bold letter, okay, in book. It's still the vector, okay? All right, so as for multiple direction, right? So you don't have a S means like one direction only, like, X or Y. You do have like multiple directions. In that case, obviously, every day you want to take the class note because you are going to have the access of this, what I'm doing, okay? In that case, you have this R vector can be written as, so far you know that, right? This unit vectors, I, J, and K will going to be used with X, Y, and Z, right? So, and Z is K. I, J, and K's are the unit vectors, okay? And to find the magnitude, you have seen it in from the Pythagorean, right? Like you have to do like the square of all those X, Y, and Z and square root of that. Ever remember that? Okay, so that's the thing that I've been writing next. It's the magnitude. Two ways you can write the magnitude. You can use this, or you can simply write R without any line on the top, okay? That's the magnitude. And the magnitude can be written as X square, Y square, and Z square. Probably nothing new that you have learned so far, right? This is what you have seen in physics class, most likely, everyone. All right. But you're going to have something new for sure once you're done with the math, right? Maybe not, depending on your physics class level, okay? Sometimes you are really expert on these physics things. Anyway, so that's pretty much it with the position, right? Now let's focus on the velocity. On the velocity itself, you have this position with respect to time derivative is the velocity. That's what I've seen before, right? But instead of R prime, what did you use? S, because previously we just didn't have the vector. Now we have this 3-axis dependence came on. So you have this R, right? Now when you do the derivative, that's the interesting part. You see in the math, in the example math that I have shortly, you'll be seeing like you got to do the derivative and for 3 different axes, right? Does it make sense? And you would be adding them up by using those unit vector I, J, and K. Okay, so just to give a flashlight what is coming. So basically all I'm saying here, you're going to have this 3 component of the velocity Vx, Vy, and Vg, right? This remember this Vx, Vy, and Vg, those are the magnitude of the velocity in these 3 different directions, X, Y, and Z, right? So how to find those three values, like this Vx or this Vy or this Vz, right? How to find them? Now it comes to become like the simple thing that you learn for 1D case, right? This Vx would be dx over dt. It makes sense? So you have this dx over dt. Now remember, you had this ds before. Now you have this x1z came up. So that's why you got to do this dx over dt, dy over dt, and dz over dt. Everyone understand so far? Any question? Take your time, finish the note. All right, and obviously, like just like before, what if you are interested to find the magnitude? And again, the magnitude can be written as, the absolute sign of this v vector, right? Or the v itself. Now, how do you find that? Any idea? You want to do the same thing, Pythagorean, right? Which is obviously square root of what? These three different components, vx square, vy square, and finally vz square. How about that? Everyone agree so far? If you understood so far whatever I just covered, I bet you can able to deal with the other thing as well, which is the acceleration. Similar thing, right? You can deal with the acceleration, maybe? Okay, take your time, finish the note. Let me know when you're done. If you have any question, also let me know, okay? And now the crucial thing is, now that you don't have the access of this one note, like before, you got to take the class note, okay? Otherwise, you'll be in trouble later on. Unless if you'd like to watch the video. Okay. I don't think we will probably need the whole class time. Because the math that we'll be doing, if you understand this, whatever I was just showing so far, you'll be golden. I mean, obviously, you need to know a little bit about the derivative and the integration knowledge. Remember, we learned those already. It's not that bad. Done with the writing. I'm seeing everyone. Okay, perfect. So the acceleration, the final thing, right? Which is the acceleration A bar. The bar, not the bar, is the line on the top. You can say this the vector of the acceleration, and this time we'll be doing the derivative of the velocity with respect to time t, right? And then obviously, like the velocity, you have these three components, x, y, and z, right? So how am I write it? So like ax, I, ay, j, all the unit vectors I, j, and k, right? A, z, k. So you have these three different components of the acceleration, ax, ay, and az. I am very positive that you kind of already have an idea that how to deal with those three components, right? Like just before. So you want to do like what? Like these three components of this v, vx, vy, and vz, you're going to kind of bring them here for this ax, ay, and az. Just for the first one. You see, you have the vx with respect to time t, derivative of vx with respect to time t, right? So that's the acceleration in x direction. Can you deal with the other two, like y and z? Should be. So a y should be dvy dt, and az should be dvz dt. Agreed? All right. If that's the case, then let's just focus a little bit more. I mean, time to time in your book, you'll be seeing instead of ax, they oftentimes use this bx dot. So this dot that you're seeing on the top of the v is referring per unit time. That's the case for any other subject. Like you take thermo, heat transfer, fluid. Every time you see a dot on the top of something, that's referring per unit time. You know that, right? You might have seen it before in different classes. A dot on the top of Q for my thermo class. If you didn't take thermo. In fluid class, maybe flow rate. Or I don't know, whatever classes you take. A dot is always per unit time. So that clearly tells you if you're going to put a dot on the top of the V is the velocity, right? This per unit velocity is what? The acceleration. Does it ring a bell? So the velocity divided by time is what? Acceleration, right? Yeah, so the dot is clear, right? With the dot thing, you're going to remember. Now, why I'm emphasizing on that, in the problem, in the book, in the exercise, example, everywhere you see the dot, they use it. Okay, so don't get surprised. The same thing. So if you have this Rx, then how many dots do you want to put? One dot or two dot? Two dot, because R is the one, distance, remember? So distance one time derivative is the velocity. This velocity derivative is the acceleration. So you got to put a two dot, okay? And that's what you'll be seeing all the time. So if you understand so far what I just said, right, then you should be able to write for the others as well. Like, you can write this Vy, Ry, two dot. You can write this Vz, one dot, Rz, two dot. Agree? All right. So these are the terms and symbols that you will be needing in your math now. And take your time, finish this. We're going to start the math. And I said, I just have one simple agenda, just one math for today's class, okay? I like this class as three different meetings in a week, so I can go slow and not too much material in one class. In one class, I do have for 3 credits 2 settings, and I have to unfortunately cover too much. And sometimes absorbing too much is difficult or challenging. Okay, so moving on, right? Let me know when you guys are done with the writing. Perfect. Let's start to read the problem and see if you understand this problem. So what is saying here, Carl operated a radio control model car. I mean, we do have bunch in our lab, right? 111 radio control model car. On a smooth, flat cement playground, which we have the perfectly in our classroom or lab class. The girls stand at the origin of X and Y coordinate system, and the surface of the cement line is in XY plane. Assume we have some line XY plane on the surface, like here or on that room. All right. So then it says here. So the car's position is given by. So they have this R and. So the car's position. Just one second. The car's position is given by. They have this R in the function of x and y, obviously x and y, just 2D case. And the velocity component was given by x dot equal a function of time. The same thing, y dot equal a function of time. Equations, basically, right? So both of them are polynomial equations. So basically, x and y have a t dependence, a second order and third order polynomial. So it's not a straightforward one, okay? And they give you the velocities. You have to understand in x and y direction. Why? Because you see, first of all, they said it's velocity. Second of all, they have it x dot and y dot. You notice that, right? You remember when you have one dot, that means velocity or acceleration? Velocity. And two dot means acceleration, remember? And that's for the positions, right? And x and y are the x and y coordinate system positions, right? Everything's good so far? This is the crucial part to understand. So they gave you basically x and y component of those two different two velocities. Okay. So what does it really mean? Does it mean like the car is running in x direction first with some velocity and y direction first with some velocity? What do you think? No. The car is running in 2D, like zigzag, whatever way it is doing, right? When it is running, at every point, that car has an x direction velocity and a y direction velocity. Does it make sense? You understand what I'm saying? All right. So that x dot and y dot is referring obviously that for sure, right? So also the other thing they, in the given way, they gave you like the start button where the lady or the car is using the remote to run the RC car. Okay. So that's location is 2 and 6, right? X position is 2 and y position is 6, right? That's a given, right? So this actually technically the coordinate and x and y velocities are given. What they're asking? That's the question. So the first thing they are asking, determine as a function of time the position, velocity, and acceleration of the car. So they gave you the velocity already, right? Position of time. Yeah? So how do you find the velocity and how do you find the acceleration? Finding the acceleration is the easiest one. Why? Because you just have to do derivative. Is the derivative is easier or acceleration is integration is easier? Derivatives are easier, right? I mean that's how I felt when I was a student. I hope you guys are feeling the same way. So finding the acceleration, is it a difficult thing? No. I just have two axis velocities given, x and y. So we're gonna find the acceleration in both directions, right? By doing the derivative. One more time, like with respect to time t, obviously. Can you do that? Derivative to find the acceleration. Okay. And then can you find the position as well? For finding the position, if you're given the velocity, what did you learn so far? You're going to do derivative or integration? Integration, right? Because the velocity will be equal to ds over dt. We have seen that. Now moving that dt from right to left, and then we just have integration in both sides. Okay. Now it's all part of so far. You'll be seeing it better when I'll be starting writing. And those who are advanced and really understand everything, maybe can start to do that. What I'm saying. All right. Obviously, I'm gonna go with much more formal approach. So you have the givens. Let's start with the givens. So you have what are the things given? Like three things, right? X dot. By the way, this x dot is Vx. We just seen that in the theory, right? Is dx over dt. We've seen all of it equal to 2 plus 3t square meter per second. Now, here's the thing. The thing that I wrote is the x dot is the velocity, right? I said like is the x component Vx or is dx over dt. You can literally write any of this thing or all of this thing. Is it clear to everyone? It's all the same thing is referring. So if you understand that, so then you understand this y dot and this Vy or this dy over dt is the same thing. And they gave you a value for that as well. So is it like t cube, like 0.5 t cube? Is this 0.5? I got to check. Yeah, it's 0.5. All right, so these are givens, what we're trying to find. So let's just, I mean, it does have so many things to find. Like, let's just focus on number one, okay? Others, I have a result here. I wish I had, yep, I have a result here. So that will kind of help you to find that, okay? Because for the others, you want to use the computer program or Excel or something, okay? But just find the first one first, okay? I know I'm wandering here and there. I'm going to give it show to you, okay, and stay it for a while. Let me just finish the question, okay? Just one more second. So you are given with the two velocities, x dot and y dot, where t is the time in second. So they said here at time t equal to 0, the car is located at x equal to 2, y equal to 6. Okay, what does it mean? You see, the car is standing at 0, 0, but car is located at x equal to 2 and y equal to 6 here, right? At time t equal to 0. Everybody see that on the sketch? All right. So then it's saying here, for part B, it says what happened when time t equal to 2 seconds, but we are not focusing on that. Let's focus on part A. On part A, they were saying determine as a function of time, position, velocity, acceleration of the car. Okay, that's what we'll be doing. So that's why I was saying, like, let me just show it to you on the problem itself, then come back here where we left off. So they were saying, okay, let me start writing. So they're saying find, okay, what we're trying to find? The position as a function of time, right? Means equation for the position as a function of time. They're saying find the velocity as a function of time as well. Actually, that part is given already in the question. You know, x dot y dot given. Just have to write it in terms of x dot I unit vector plus y dot j. So then final thing is the acceleration with respect to time. And did you guys notice that I put a bar on the top of these three parameters, AV and R, because those are vectors. And those vectors does have only two components, x and y, not z, because it's a 2D problem. Okay, take your time, let me know. And once we're done with this, just part A, then we are done, because the other part solution, I have it from the computer already here. So that's part A. So basically, those who understand already how to deal with that, you can actually start doing that. As I said, like you gotta do some derivative, right, to find the acceleration. You gotta do some integration to find the position, right? Those who really understood, please try that. I don't want to resist you. If you are done, just show me your answer. If it matches, you can go. Those who need help, just please pay attention what I'm doing. So the solution, right? So how to solve this problem? Remember, you had these three things that you gotta find, and one of the answers is already given, the velocity, because x dot is the x component of the velocity, y dot is what? The y component of the velocity, right, Arlene? You got it? So just let me write it, and then the first part is done, which is the velocity. So let me write the velocity equation where I have this. You can write it Vx, okay, I, Vy, J, or the same thing can be written as what? X dot I, Y dot J. I want everybody to pay attention here, like different way of writing things. If you don't understand that, you'll be in trouble, okay? When you're seeing in problem something is defined, you don't know what is saying. It's the same thing. All right, so since we do have the values for that, let me rewrite that and finish the first part, which is, what is the Vx? Isn't it 2 plus 3t square? What is the Vy? Isn't it 6 plus 0.05 t cube j? So the first part answer is, when a fraction of the first part answer is already given in the question, right? And why I even bothered to write it, because if I have the basic equation, then I can do the derivative and integration for these two other part of the answer, right? All right, so that's how I'm proceeding. All right, so now if you're trying, take your time. If you have a question, let me know. So now, if you're trying to find the acceleration, you do have this ax I plus ay j. So this ax, it can be written several ways. Can it be written like dvx over dt I dvy over dt j. Can it be written this way? So what does it really mean? You just have to do the derivative of vx, and you just have to do the derivative of vy, and plug those values here. That's your answer of acceleration. Do you guys agree? Okay. If you do, let me put an equation number, right? How about that? This one is my equation number 1. And then let me try to deal with that ax, okay, separately. And then I'll bring back the equation. So I have this dvx over dt. And then instead of vx, I'm going to simply write this 2 plus 3t squared. Okay. And then I'm going to do this like this way. I don't know if you recall. Did you guys recall how to do derivative? Just the addition rule, separate that. The first one is obviously 0. If you're trying to do a derivative of a constant, what is that? Is it 0? Okay, what is the second one? Yeah, 60. Why? Because you see, the side note is important here. Let me remind you, okay? So if you have like this x to the power n d, this is not the integration I'm doing. Sorry, d by dt, right? This one would become n x to the power n minus 1. Is it clear to everyone? And you do have like what? Let's do the example. You have 3t squared. So that's why I see students oftentimes get confused. Anytime you have a constant multiplied with something, you don't do anything with that constant. You just bring it out from the derivative that you are doing. In this case, you have 3t squared. So what are you going to do with the 3? You don't do derivative integration, nothing on this. You just bring it out, right? You don't need to do anything on that. So let's just bring it out. The 3 will gonna come out, and then you have this t square, right? sorry about that. I know. So you have this t square. It doesn't look quite great. Let me try to redo it. So you have this 3 and you have this t square, right? And then on this integration, on this derivative, you know your n value is 2. Do you guys agree? So you already had the 3. This 2 are going to come at the front, and then you have 2 minus 1. So which you're going to tell you is 6t. I really don't understand. You guys understand this, everybody? The derivative that I did? So 3 was with that. I took it out, 3, right? So what I had, t squared. So if I had the t squared, 2 is like n. I just did that equation. So if you understand that, can you finish that math? I think some of you already finished it, right? So what I'll be doing next, obviously, so I'm gonna say like, okay, this is my 0, right? And I have this 6t here. So that's my ax. Okay, what is my ay? My ay should be equal dvy over dt. And my dvy is 6 plus 0.5 t cube. Okay, so ay can be written as the same thing. So this thing would be 0, right? d by dt, I have this 0.5 t cube. And then I'm going to have this 0.5 is going to come at the front. And then 3 is going to come here. And then t square. And that's my ay. I can rewrite that as 1.5 t square. Right? If that's the case, so then my a or acceleration can be written as ax. That's from, again, equation number 1, right? So axi plus ayj. Oh, the y looks a little weird. Let me try to rewrite. Ayj. Okay. Now you do have the values of ax and ay. Just simply need to plug them, right? So you do have this, okay, 6t I plus 1.5 t square j. And that's my vector for acceleration. Now, anytime you'd like to find for any particular time the acceleration, say like t equal to 2, what are you going to do? Just plug the value of t equal to 2 for this equation, right? You should be able to get acceleration. Now, if you're interested to find the acceleration, the magnitude of it, not the vector, the Pythagorean equation, right? Square root of x square plus square root of x square plus ay square. Remember that equation? Does it ring a bell? Maybe not, right? Maybe you'd like to see it again one more time. You guys remember the Pythagorean equation? And for acceleration, the same thing can be done, right? Ax square plus ay square plus az square. I didn't quite write it, but you kind of get the idea, right? It just follows the same thing. All right, that's the acceleration. I'd like to give you some time to absorb. So now the final thing is the position. All right. To deal with the position, we just have to do the integration. That's a difficult one. Okay. As I said, like if you feel like you are really good at math or kind of at this point in the advanced stage, you can do the integration. If you're done with the integration, show me the results and if it matches, then you go. That's the thing. That's just like kind of giving you the reward to be engaged. Okay. Try it by yourself. If not, it's fine. Just need a little bit more brush up on the memory of integration and derivatives. Okay. Slowly you're gonna get it. All right, so let me know when you're done. If you need some time. Anybody need any more time? Do you want me to move on the final thing? Final thing? All right, so final thing. What you are trying to find? The velocity done, acceleration done, what left? The position, and it's a 2D dependent case, so x and y only. Okay, x plus I and j plus. Okay, so find what you got to find. You got to find the x value, right? And you got to find the y as well. Okay, let's try to deal with that. So you are given with the Vx value, right? That's from the beginning. And you are given with the Vy value. That's from the beginning. You got to deal with those somehow, right? Now, tell me if you agree with me that Vx is same as dx dt. You guys agree with me? The same thing can be written as, okay, see if you can agree with me. Is it same as dy dt? Should be. All right, then can I rearrange? I mean, instead of me writing the Vx again, this 2 plus 3t, this is also written as x dot and this is also written as y dot. You know that. Okay, I'm writing the whole thing lanyard. Okay, so you won't be getting confused. So can I rewrite that as like dx and then this 2 plus 3t square dt and do the integration in both sides? Can I do that? I'm just rearranging things, nothing new. All right, and then you're going to put some limit on, right? What kind of limit you want to put? For x, where did it start? The value of x, the car? 2, right? So I can start with 2 and I can write it can go up to the value of x equal to x. We don't know yet. We'd like to solve it such a way so it's a generic solution, right? Not for any particular position. Is it clear? Everything good? All right. So what if? So what would be the time when x value is 2? Like remember the initial position was 2 and 6. It would be 0, right? And the time it would be the same generic, right? If it goes like t time equal to t x, then I would be writing the upper limit as t. Do you guys agree? It's very important to understand the limits, how to write it. So again, starting point of x is 2. That's why I wrote 2 at the bottom, lower limit. And x upper limit means at any point I'm talking, right? I'm really not specifying at what point it stops. The car is running all the time, right? And the t is referring to generic as well. So now that I have the integration set up, can you deal with that? So I obviously have this integration written as 2 to x, agreed, upper and lower limit. That thing I'm probably solving it like 4 or 5 times already in this class. Okay, anytime you don't have anything inside the integration, you just have to write that with respect to integration, like here dx, you just have to write that x variable and put the limit. Is it clear? Instead of dx, if I could have a dt, then I should have write t here, right? It's just a variable. Okay, now I do have these two different things, like, I have this integration of 2, and I know if I'm gonna do it in one time, one setting, then I'm gonna lose some of you. So I don't want to lose any of you. So these 2 and 3t square, I'll separate them. So before you understand the integration, see if you understand this line, the last line I wrote. Did you understand this last line? Because if I'm gonna do it in one step, I know I may lose some of you. So that's why I'm doing it, like separating them, right? We still have the same limits. So now if you understand that, then this is just a simple problem. Like this 2 is nothing to do with the integration. It's gonna come out, right? So and the same way, and the same way, like the way I wrote, if I have a dx then x, the same way I'm gonna have a t, right? Okay, so the same way I'm gonna have a t, and the limit would be 0 to t. Does this make sense? Okay, and the right one, I have this 3. I don't worry about that 3. It's not gonna come out, right? So I have this t squared. If you do the integration of t squared, what will happen? T to the power 3 divided by 3, right? Because for integration it is what? X to the power n plus 1 divided by n plus 1, remember? So n is 3 here, right? Yeah, and then you have this 0 to t, so I'll just write the similar way, and then finally I'll solve it. So finish that, and finish the y as well, those who understand. And what is the question? No. You good? You good? Tell you you're good? Everything's good, right? Okay, so then obviously I do have this x minus 2 here. equal, I have this 2t, I'm gonna just increase one more steps. I have this 3 t cube divided by 3, 0 to t. You understand? Okay. So I have this x minus 2 equal 2t plus 3t cube divided by 3. 3 and 3 are going to cancel out. Okay. And then I'm going to have the final line would be x equal, this 2 is going to go on the right side. So negative 2 will become positive 2 plus 2t plus t cube. So I'm going to put a box around it and see if you really understand. Okay, if that's the case, then let's focus on the other one. So the other one is, I'm going to rearrange things just like before, and this time I'm going to do a little shortcut, right? Because the same thing. So I have this dy, right? And then I have this 6 plus 0.5 t cube dt. Do you guys understand? Okay. And if you understand, why don't you finish it? So what to finish here? Just like the previous one, okay?
You want the answer?
You do have the answer. So is it like 6 plus 6t plus t to the power 4 divided by 8? You are done. You can go. All right. If you haven't finished it yet, whoever finished it, okay, I'll see you, okay?
Okay.
Okay, let me finish it, okay? Is y and the limit that I gotta put it here as well. So I have this 6 and y, and I have this 0 to t, and that's a little bit difficult to understand. Why is the lower limit 6? Remember, you had the initial position is at 2 and 6, right? So 2 in x direction, 6 in y direction. That's your initial position. That's why I wrote the lower limit 6. And why did I put the upper limit as y? Because the y is generic, right? When it started, the radical started from say like 2 to 6 here position, right? It is gonna go everywhere, right? Whenever it is gonna go everywhere, what is gonna happen? The y position changes, right? So that's why it's generic. The same thing is with the time. Initially, when the y location is at 6, like x location is 2, x equal to y equal to 6, sorry. Initially, what does means? That's time equal to 0, okay? That's why the limit for the time is 0. Okay, so then I'll just simply do that just the way I did the previous one. This time I'm not going to separate the integration, but you know I had to do it just similar thing. So I have this 6 t 0 to t plus I have this 0.5, and then I have this t to the power 4 divided by 4, 0 to t, right? And then I'll have this y minus 6 equal, I have this 6t plus I have this 0.5 means half, and then I have this 4 t to the power 4, and then I can rewrite that as 6 plus 6t plus 8 t to the power 4. That's my y value. Okay, I now have this y value, and I had this x value before, so I can write the position x I and y j, right? And then I'm gonna write the value of the x as like 2 plus 2t plus t cube as x and I as a unit vector, and I can write 6 plus 6t plus t to the power 4 divided by 8j. So that's my r vector. Again, what is my r vector? R is the position. So what you're seeing so far in this class, you really need to be very good, or you should be doing review on derivative and integration. Okay, if you are not good at that, I'd suggest to get a tutor. Otherwise, you'll be struggling from the beginning to the end of the semester. Or you come talk with me anytime. I'll try my best to give you the understanding. Okay, with the integration and derivative. But in any case, the bottom line here, you gotta know the derivative and integration. Okay, there is no way around. Okay, to understand this course, no way around, none. All right. So the other question answer is obviously on the figure. I can talk a little bit on that in next class. For now, since the time is over, I don't want to go any further. Okay, I'll see you on Wednesday. Okay.